All right, we're moving through fairly quickly because this is conceptually a summary of what we're trying to achieve. The tools to achieve that were covered the previous days. Some of these tools you need to sit down with and work your way through because it's a progressive process you must go through. Can be time consuming, but I don't apologise for that because we're trying to understand where the risks really are. And if that takes a bit of time to get a full picture of the operating risks, then it's a good investment. Another day of getting the right answers is a good investment. In the end, it's all about reducing risk in the operating phase of life because the money is made during the operations. And if I can maximise that profit by minimising my cost, by minimising my risk, by maximising my reliability, then I'm doing the right thing for the business forevermore. So I'm going to touch on again factors of physics of failure, chance and consequence reduction, and the big one, the one that most companies don't do well enough, is economic maintenance selection. I don't mind having breakdowns if it's the cheapest thing to do. So maintenance is an economic choice. The dollars drive the maintenance selection. And anything else than that approach is more expense than you need to spend. So what destroys the machines? What factors that are in the workplace? And there are dozens and dozens of ways to break parts. If any of these are in your business or are possible in your business, we want to identify them. You know, this bearing in that motor, how can that bearing be failed by this business? And this list is just to trigger those thoughts. We can do brainstorming, nothing wrong with that, but that won't be enough because we don't know it all. No one knows it all. So we're going to have brainstorming if we have brainstorming to get people involved in the answers and coming up with the solutions as a human factors type approach, great. But if you're going to brainstorm, also bring out this list and say, guys, we've covered half of this. What about the rest? Can any of these other ones we haven't yet touched on be factors here? Because I want to find everything that can break the machine. I won't necessarily solve every single possibility. The risk matrix and the financial benefit of doing that will decide that for me, but I don't want to miss anything. So we're going to have spreadsheets, literally we're going to, as the guys answer those questions, as we decide off that list what is applicable, possible in this company, we're going to write those down, what situations can lead to those, and then we're going to start developing answers. Now these answers are going to be right procedures, ensure a person's training is to this level. So these answers are going to roll up into our processes that run the business. That's how we find what to do and put the right thing in place at the right time. We'll actually go as far as specifying who's responsible for that solution. This particular colour in here, as we decide what the problem is, where it comes from in the life cycle. If the problem comes from the manufacturer or comes from an engineering selection decision made 20 years ago, we're going to make very clear who's responsible to get that answer right. Not to be nasty and mean about it, but just to allocate responsibility and ensure that they have got procedures that prevent these things happening. Now, we're not talking here about heaven. This is not about being perfect. This is about being better, about excellence, moving forward in the right direction all the time. We're not going to get them all. You know? There will still be breakdowns. The world... Now, if there's an earthquake and it destroys something, or there's a lightning strike and it blows up the PLC on the process control computer, you know, those sort of things will always happen. Our job is to achieve excellence, minimise that right down. Lightning strikes we can protect against by making sure the current goes to earth and not through our equipment. You know, there are things that we can do, but human beings, I'll make mistakes. And managers make mistakes and they will snowball through. So yeah, we're going to have the occasional one, but because our process is improving all the time, we're going to find those, remove them, and it'll get better over the years. So don't expect heaven, but this is a far better way to ensure that you'll get the outcomes you want on a regular basis. Always, dollars and cents drive the decision making. So yeah, in terms of reducing chance, we're going to introduce chance, we're going to introduce stress reduction best practices immediately. So easy, so obvious. So obvious now that best practice is best practice because it produces best results. Anything less than that is not best practice. If our company is to be number one best practice user and be doing the best of the best practices, then bring them in immediately. Bring them in immediately. You start making money much faster. We're going to protect against past distortion and degradation across the whole life cycle by every group in the company. We're going to have H3T standards as a life cycle documentation requirements to reduce human error. That's what it's all about. And human error and the mistakes that human beings make is what we're trying to minimise here. And of course the doctor is the decision making made many years ago that will now roll on through forevermore in our company. Here's an example of economic decision making. Here's a gearbox, or an assembly drawing of a gearbox. This particular gearbox costs $2,500. It's only that big and the shaft comes out. It's probably that long and that size. It's not a big gearbox. It might be a 5 kilowatt motor. It's not massive, but it's $2,500. Now the question becomes, as a maintenance strategy, do I restore this machine on a regular basis and do an overhaul and a shutdown and fix it back to supposedly good condition, or do I replace it brand new? This is what we know of the machine, the reliability curve. We know that for the first 3 years in a group of 100 machines, only one in that group has failed. So for 3 years and doing no maintenance on that machine for 3 years, 1 out of 100, so 99 times out of 100, we're going to make 3 years with no maintenance being done. The question now becomes, at the end of 3 years, do I replace it with new or do I maintain it and renew it back to the condition? Bearing in mind, each failure is $25,000 company-wide loss. Now, this curve falls away because as parts age, more of these things start to fatigue, more opportunities for failure arise, and one of those every now and again pops up and the machine stops. So that curve represents the likelihood of a failure. For example, half my machines will survive 6.5 years. 99 machines will last 3 years. 10% will last 8 years. I might be lucky. I might have one of the 10 percenters. I'll never know. Can I afford to take the risk of thinking I've got one of the 10 percenters if each failure is $25,000? This is where risk and the financial justification has to be number one. Most guys, they'll push the limit. Most managers will say, run that another 6 months. Oh, I can't afford it this month, we haven't met budget. Run another 6 months. Well, Mr. Manager, another 6 months is 3 breakdowns. You're going to lose $75,000 because you're not meeting budget. This is what we have to make clear to production and engineers and CEOs and executives. The game they're really playing. They're playing a game of dice, unless they've got the data to understand what really is going on. So we're back here. The question is, maintenance strategy-wise, I've got 2 choices. I can, 4 years, I might push 4 years, 90% is, 90%, I might get away. I might be lucky, I might have one of the 90 percenters. But if I got one of these 10 percenters in the first 5 years, which I'll never know, I've got one of those. So if I say, well, forget about replacing it in 3 years, we'll push to 5-year limit. Let's push this to a 5-year limit. So 90 times out of 100, that machine or that gearbox will last. But that's 10% chance. Are you willing to risk that? This is the bit that it might be okay. It's not a bad odds. It's not bad odds to push your luck, but can you afford to push your luck is the question. So let's, if I replace the gearbox, if I just say, look, I'm not willing to take the risk. I can't afford to lose $25,000, have a 10% chance of losing $25,000. I'll accept 1% chance and I'll make sure I minimise that by doing precision maintenance and precision installation and precision operation. I'll make sure the right things are being done. That'll increase the odds in my favour. So in this case, I've chosen to replace the machine this is $2,500. 4 hours to replace. The whole job's going to take 5,000 maybe. Of course, production's got to stop for 4 hours. So that 4 hours of loss is in these $25,000. Oh, sorry, there will be 4 hours of loss that we should factor into the cost of the maintenance. But for $2,500, and I'm going to lose $25,000 each time it goes down, I begin to become clear what I should be doing. The other option, of course, was to overhaul. So we throw in the overhaul on year 3, but hey, hang on. When I overhaul a machine, when I pull it apart and try to rebuild this thing using human beings with no procedures, the odds of failure are now 30% on that next machine when it starts up on the overhaul. So now my odds are not like a new machine anymore. A new machine gives me the same odds as what it was. An overhaul gives me less odds. They get worse. Now, do I overhaul and take that risk, or do I just spend 2.5, 5 grand installed, maybe 20 grand for a 4-hour downtime, and then not do anything more for 3 years? Or do I take this punt? The numbers tell us what to do. Of course, if I can increase reliability twice as much, if I can go from 3 years to 6 years with absolute certainty, hey, let's do that, because that's repairs that aren't being required with certainty of achieving the output that I need, the production I need. I don't know what to do, so I've got to model that. I've got to get a spreadsheet out, I've got to sit down, I've got to model my options. The cost of scheduled over restoration versus scheduled replacement. Here we go, $7,500 every 3 years versus $15,000 every 3 years if I overhaul and restore. It becomes obvious what to do. The only way I'm confident is I've modelled my options financially. So in maintenance, if you aren't doing financial modelling, you aren't doing maintenance properly. You're making the wrong choices because you're guessing. You're guessing, oh yeah, but this guy's a 30-year man. You know, I'm a 25. I built machines, I installed machines, I slept with machines, I maintain machines. Hey, I should know what I'm doing. It's a guess. I don't know what I'm doing for certain until I model the financial consequences of that. So yes, in PEW, we require the numbers to drive the decision.